9-7. Solving quadratic equations using square roots. This is kind of like the last one we were doing, was solving by factoring in, that it works in certain special cases. This is going to be easier to see when it works. So that's just where I'm going to start. So kind of a disclaimer, as you're taking your test, taking your quiz, you can use this when. So works when the b value equals 0. So works when the b value equals 0. By that, what I mean is, and you could skip this if you already kind of know it, but we've been talking about quadratic equations being in the form of ax squared plus bx plus c, right? So if that b is 0, it's kind of like I have 0 x's in the middle. If you have 0 x's, do you even write it? No. So in other words, this is going to work when you have some number of x squareds and some number at the end. So in other words, it works with when you have no x to the first term. So when you don't have an x to the first in your quadratic equation, it works. Now here's the one difficult thing about the most difficult thing about this section is this, that you have to remember when you do square root of x squared. I think we did that earlier this year. You may remember, it doesn't just equal x, it equals the absolute value of x. Now, I think the toughest part of this section is remembering that when you get to close to your last step, perhaps, maybe your last step, and you do this absolute value of x squared, you have to make it equal the absolute value of x. It's easy to forget that, and then you only get half of your answer. All right, so let's do a couple. So example 1. If I have an x squared minus 169 equals 0. So we could try to do solving by factoring. We could put it in our graphing calculator and graph and trace. We could find, use that equation, x equals negative b over 2a. But if we're going to do one like this here, one way to do it is just say, okay, let's solve this thing for x. Well, do you agree to get x by itself? First step is to move that 169, right? And I could do that by adding 169 to both sides to cancel out it on the left. So I have an x squared equals positive 169. Still tracking with me? All right. Now if we want to get x by itself, we have to undo the squared. You undo square by square rooting. So whatever I do to the left side, I have to do to the right side. So square root of 169 equals 13. But like I said just a moment ago, the hardest part I think in here is remembering when you do the square root of x squared, that doesn't equal x, it equals absolute value of x. Which typically our parabolas are going to cross the x-axis how many times? 2. Usually, do you agree they cross the x-axis twice? It's this absolute value that gives us our two different answers. Because we can take this now and say, all right, what could I have right here inside my x squared, right inside my absolute value? Do you agree that it could be a 13? So I could have a x equals 13. That'd be because absolute value of 13 equals my 13, right? Or x could be negative 13, because if I'm right here, I could have absolute value of negative 13 also gives me the positive 13. So that right there now are going to be my two x-intercepts, the two x values that satisfy that first equation, that make that first equation equal 0. How are we doing? You guys okay on that? A second example. So in my example 2, I'm going to try to give you something that's a little bit different. Let's say I have an x squared plus 7 equals 7. What's my first step in solving this one? Minus 7. That gives me an x squared on the left, and on the right I have a 0. Okay, now to solve for x, what do I do to both sides? Square root. Square root of 0 equals 0. So I'm left not with x equals 0. Yeah, okay. Absolute value of x equals 0, right? So my two options for x are now x could be 0 or, well, x could be 0, right? That's, yeah. You can't really have a negative 0. So in this case, I just have one solution. Which now, what does that tell us about our parabola? What point of the parabola is on the x-axis? The name starts with a V? Vertex. So this parabola now is going to be something like, this here, that its vertex, it only touches the x-axis at one spot, and that spot happens to be 0. We okay for example 2? All right, example 3, you want to give you something a little bit different. Example 3 is the one where you may not always get a nice pretty answer. So 16x squared minus 49 equals 0. First step. Nice. Nice to hear so many people with me. So I have 16x squared equals a positive 49. Next step is to, good, divide by 16. I'm left with x squared equals 3.0625. Yep, so now we square root it. And I made this work out kind of nicely. I have a 1.75 on the right, and on the left I have, good, absolute value of x. So now my two different solutions are going to be x equals 1.75 or negative 1.75. So I have those two x-intercepts. My parabola crosses the x-axis in those two spots. Not bad, right, compared to what we were doing?
I did not think it was easy.
Example 4. Don't you love it when the teacher says not bad right before giving you the last example? Okay, this here. You have a garden wall. Of course, a story problem. End with a fun one.
Those are my favorites.
They're everyone's favorites. Twice as long as it is wide. Really what we're doing is we're doing like an additional step kind of towards the beginning, but the solving it's going to be the same as what we've been doing. So you have a garden wall, it's twice as long as it is wide. The area is 578, that'd be square feet. I squeeze my little 2 in there. And the question is, what are its dimensions? Sometimes knowing how to start is really the roughest part. So you finish copying that down. Does anybody see a good way to start, or at least a way to start? We're going to have a rectangle. What's the equation for area of a rectangle? Length times width, right? So I'm maybe just going to start writing, okay, so area is going to be length times width. And sure, I could put the area over here on the right also. It'll look a little prettier at the end maybe, but okay. What do we know about the area? See, so much easier when I put the area over. Okay, area is 578. Now the length and width are really kind of our problem. Well, if I were to have a garden, a nice rectangular garden like that, the only thing we know is it's twice as long as it is wide. We don't know either, so how about I say this is going to be an x? If that's an x, what does my other side have to be? I just didn't hear people. It's twice as long as it is wide, 2x. And if you're ever not sure, I heard like an x squared. If you're ever not sure, try putting numbers in there. Let's say this is 5. Something that's twice as long as 5 is going to be 10, right? So then what do you do to 5 to get 10? You don't square it, you double it. You multiply by 2. So that could help you see then if this is x, now that would have to be the 2x, maybe. I'll sometimes do that if I don't know how to do a problem with the algebra. I'll try it with numbers, and that helps make the algebra easier. Okay, so I just made up like a number for the width, and then I said, okay, what does the length have to be? And then I could use that to derive my equation with my x. So now we need to put in our 2x and our x. So I have 2x times x, or you could do the other order, x times 2x equals 578. Next step, I could say this is 2x squared equals 578. Now we're right back to where we have been doing the last couple problems. So my first step in solving is to divide by 2. Now I get x squared equals 289. Square root those, and I get a 17. Technically I have the absolute value of x though, right? So we're trying to find x. What is x? X is the length of this side up here. So as I find my x, I know that mathematically x could be 17 or x could be negative 17. Mathematically, these are my two solutions for x. Do they both actually make sense in our story problem? No, you can't have a negative length for your garden. That makes no sense. Instead, you have to have it being x is going to be positive 17. So to finish the problem, though, if the problem is really saying what are its dimensions, well, you could say its dimensions, it's going to be 17 feet because I have these feet squared by, what's this side here have to be? 34, yep. You have 2 times the 17 gives you the 34 feet for the other side. I found there was a lot of confusion after leaving the notes right there, so I want to throw 2 more things in that'll help make things a little bit easier to understand. First of all, as we've gone through and found answers like x equals 13 or x equals negative 13, what are we really finding? Well, if we were to have a parabola, our parabolas are U-shaped, and typically they're going to hit the x-axis in 2 places. And what we're finding is we're finding those 2 x-intercepts. So x equals 13, that's saying, all right there, I have an x-intercept at 13, and right here I have another one at negative 13. So now the problem comes in if you end up with a situation with a parabola that doesn't ever actually cross the x-axis. So it could be entirely up above, it could be entirely down below. So if we have an equation for this parabola, maybe it's something like x squared plus 7 equals 0. And we're trying to figure out, well, when is the y value 0? Or you could kind of look at it like y equals x squared plus 7. We're saying when is y equal to 0? And there isn't a place. There are no x-intercepts anywhere along here. The parabola just doesn't hit it. Well, what happens when you try to solve this problem would be, all right, first thing is we move this 7 to the other side, and then I have my x squared equals a negative 7. And now if I were to do my square root like we were doing before, I have my absolute value of x over here on this side. But now when I take and punch this number into my calculator, it's not that I get a weird decimal, it's that I get an error symbol. And the reason is, if we back up, so we'll just say domain error, it'll say, if you have a graphing calculator at least. And what's really happening is this. Back where we had the line x squared equals negative 7, well, if you think, if I take and put a positive number in there, squaring a positive number gives me a positive answer. If I put a negative number in here for x, a negative number squared, a negative number times itself, times another negative, also gives me a positive. So what happens is, there's no way I could come up with a negative answer there. That no matter what I put in for x, I'm always going to end up with a positive number once I square it. So if you have a situation like this then, where as you go through you end up trying to do the square root of a negative number, you get an error, that's because we're looking back at this saying, well, what are the x-intercepts? There are no x-intercepts. Okay, another type of problem you're going to see, it's rare here, but you'll see it a lot more often when you do Algebra 2, is you'll get a problem like this, where we don't just have an x squared, we have something else inside there. Well, first thing that you do is you have to, if there had been like a plus 6, we'd have to subtract 6 from both sides, but given that there's not, we have to get rid of that squared just like we've been doing before. And when we do that, just like before, this square root sign is going to cancel with my 2 and leave me this x plus 5. But because we did the square root of something squared, we need to put in absolute value. Square root of 7 over on this side, square root of 49 rather, on this side gives me a 7. So now I could take and break this thing up, and this right here inside, well, that could be 7, because the absolute value of 7 equals 7. So I then could say, all right, x plus 5 equals 7. My other option is right inside here. That could have been a negative 7, because the absolute value of negative 7 would give me a positive 7. So my x plus 5 could be a negative 7. And now I go through and have to solve both of these. So I would subtract 5 from both sides and do the same thing here. And then I get a x equals 2 or x equals negative 12. So what's happening now in one like this is where before all our parabolas that we've done have been kind of like centered on the origin, like this top one right there. Now what we have is we have a parabola that's shifted over. This parabola now is going to be something more like this here, that one x-intercept is a negative 12, the other one is going to be a 2. Not quite drawn to scale, but that's how you solve ones like that. And that should cover most of the issues that you're going to see in this section of the book.